This is my presentation for Lab 2, Charge Tape Revisited. So, introduction, some key concepts were gravitational force, which is the downward naturally occurring force of weight. We have Coulomb's law, which is a repulsive force between 2 point charges. We have the electric field from a point charge, which is the effect that the point charges can cause in space. And evenly distributed charge, which is the ratio of charge in each piece of N. Initials, we have the mass of tape, which is 0.0002 kilograms. The net charge on one tape is 1.2 e to the negative 8. And the distance between the tape is 0.05 meters. A brief overview, the magnitude of the electric force would be 1.875 e to the negative 4th newtons, and the magnitude of the gravitational force is 1.962 e to the negative 4th newtons, and we see that these values are almost the same. To the experiment, we extract data from Lab 1, masses, net charge, and one tape, and the distance between tape. Edit the code according to with previous code from Lab 1, initials, and other key concepts, and edit the code so it appears aesthetically pleasing. You don't have to do that, but I did that so you could see the tape lines because the arrows are really big, but whatever. Code, this is just most of where I edited the code. So we have the code from Lab 0 to calculate the electric field. We also have the electric field at the location of dq due to the bottom of dq. And then we have the electric force on top of dq due to the bottom of dq. And we have the arrow line, and then my scale was very, very small. And then we also see here that this is where I put the distance between the tapes on the top tape. And this was my result. And my possible errors is that my code could have been wrong. And then I could have possibly gotten a wrong Q value and in my original lab, and then there could have been also errors in the original lab just due to like the room and possible humidity and things like that. So questions, what was the magnitude of the charge on one piece of tape as calculated by the computational model? As I said before, the electric force was 1.875 e to the negative 4th. And then the magnitude of the gravitational force was 1.962 e to the negative 4th. And because we're assuming even distributions, the values should be relatively close. What assumptions, approximations, or ideations did you have to make to determine approximately the amount of charge on the floating tape? We had to ignore air resistance and assuming that each U-tape I had made had about the same amount of charge evenly distributed along the length of the tape. The what if question says you had to model each of your tapes as a single point charge like in the previous lab. Compare the estimated value of the charge of your experiment data to produce a point charge model to the value you got with your line charge model. And I found that we would get a smaller estimation of charge because as a single point charge, you're taking a singular distance, whereas in this lab, we're breaking up the segment and adding them together. And why do these estimates differ? Which value is more likely to be closer to the real value and why? And my response was the line charge would be closer to the real value because the charge is distributed throughout the tape and not in a singular point. In conclusion, during this lab, we use concepts such as gravitational force, Coulomb's law, electric field charge, as well as evenly distributed charge to determine the electrical and gravitational force acting on evenly distributed tape. We found that using the line charge instead of point charge gave us a more accurate estimation, but we have to remember that there are very few things in the real world that are evenly charged. We found the magnitude of the electric force to be 1.875 e to the negative 4th newtons, and the magnitude of the gravitational force to be 1.962 e to the negative 4th newtons.